Welcome to another episode of Harrison Hobbies. Today we are going to be filming kind of a reaction and next step video to the Torque Test channel's review of my M18 Plug-In Adapter. That little effort to kind of circulate this, get some actual feedback, try to take this into the next step, kind of came up whenever one of my viewers had commented, hey, I should reach out, so thank you for that. So in doing that, they tested it, they had some feedback, and so I kind of wanted to do a quick recording and check out what they were doing. And in the background, I've also been getting some extra gear, so we'll kind of talk about what the next steps are here. But special thanks to the Torque Test channel for trying this out, and we'll watch the video together here.
Welcome back to the Torque Test channel. This is another one of our 4 science episodes, which have on occasion been the type where we play with things that might kill us, but in the pursuit of fun, science, often accidentally learning something along the way. So join us today as we do a bit more of that with plenty of successes and fails. Stay tuned for that. Harrison Hobbies, an up-and-coming YouTuber, after playing around with converting a Lenovo power brick to power his Milwaukee tools, took the plunge
Hey,
into
they
the
watch
deeper
my
waters
videos.
of higher wattage and sourced a big boy power supply to get all the juice out of his red tools without a battery. That is by sourcing the 120 volt we all have easy access to at the wall and converting it to 18 plus volts of Pixie power, hopefully with plenty of amps as well in the process.
Things could be getting crazy. Keep our fire extinguisher right here. Here we go, for anyone curious. 18.2 volt on here. So I think we are ready for some science. So let's just do a couple of cuts.
That's the flavor of silly science we're into, and he was nice enough to loan it to us. So today we take this abomination to the brink of its capabilities with various sizes of Milwaukee M18 impacts and see if 120 volts from the wall is enough to move the needle on these 18 volt tools compared to their existing battery options. So essentially, Mr. Harrison cracked open a no-name make-believe Milwaukee battery pack and hardlined some wires into this here 120 volt to 18 volt transformer, tripling up on the power and ground cables to try and max this thing out in the wattage department.
I've gotten a lot of questions on, excuse me, got a lot of questions on, are those 3 cables required? I figured just a consolidated comment here is that these, we can zoom in, there we go. These cables here, I'm not sure what the internal circuitry of this unit is like, and so I'm not sure if all 3 are required. My fear was that it may have 3 circuits in parallel, each delivering to those, and so I wanted to be able to get all of those. Additionally, I'm not sure what the traces are rated for in there. The power supply does seem pretty robust, but just in case, those traces are only rated for 1/3, each for 1/3 of the power, I didn't want to end up trying to overcurrent those and actually accidentally burning those up.
This box has a voltage adjustment potentiometer screw, which, let's face it, we're just going to turn up to 11, which appears to be about 20 volts. Only a nearly dead M18 battery is about 18 volts, closer to 20 volts or just above that when charged, but slumping down to 18, 17, 16 or even lower when under load, hence the 20 volt max you see from brands like DeWalt. But that's the idea at play here today. Batteries, even large ones, may start at 1 voltage and in actual use deliver another under sustained load. Brian over at Workshop Addict has a great series he's doing on just this, measuring the voltage level during different tasks using different batteries. For instance, a standard vanilla 5 amp hour XC 5.0 drilling a 1-inch hole drops to 17 volt, but a 3 5/8 inch hole, it drops to 15 volts. Smaller batteries get even worse. Larger batteries and larger cells do a bit better. Head on over there with the link below to check out that, and from brands like DeWalt as well. We've shown before that larger batteries, and particularly larger cell-containing batteries with higher discharge rates like 21700 cells, can make a bigger splash when it comes to your impact wrench. Sometimes that's less of a difference than others due to the brand's choice of cells or the tool already being maxed out, as it were. But we have seen examples where one battery might have a discharge rate advantage over a larger one, but over the course of a longer run, that higher capacity battery still making higher numbers. This isn't always the case, but in times where it is, we theorize voltage sag played more of a part on those particular tools. The load from the tool causing the batteries to drop in voltage, but on higher capacity batteries, theoretically, less so. Today, we get to see what minimal voltage sag across a long run really does as far as power goes. The 20 volts from this thing being backed up by 120 at the wall, sustaining that theoretically much better, at least up to its wattage limit. To see that, we're starting out the M18 Gen 2 mid-torque. You're looking at its original baseline best case scenario run, aka its battery freshly.
Okay, so we're all gonna see the results here for the first time together. I haven't watched this video yet, so let's see.
Shown here. I mean, usually, sometimes this thing acts like it's in mode 2 lately, but that's a discussion for another day. Now here's the mid-torque plugged in to the Harrison Hobbies House of Horrors. After very brief impacting, the hacked up imposter battery sort of slides right off. I guess that's to be expected when the release tabs are deleted.
So a little bit on the release tabs, I'd actually forgot that they were fully removed. Whenever I built this tool, it got working. I was so excited back with the Lenovo power adapters that I forgot to put them back in. Later I tried, and it's like you needed a third hand because you had to keep both of the tabs and the springs compressed in the top of the housing while you tried to put the batteries there. And I'd added capacitors where the 18650s used to be. I have all the recording from that forever ago. At some point maybe I'll post that. But you basically needed three hands, and like one hand had to be of infinite thinness to get in there. So I just said screw it. But this adapter is always on my miter saw, and so it's really not that big of a deal for me, right? It's miter saw or sometimes my M18 telescoping work light. So let's see what it does here.
Here's trying it again, but just holding that battery pack on by hand. And still no luck. So time to employ some Milwaukee Fuel approved color correct red gaffer tape to hold this sucker on. And fast forward a bit, it does work, but the connector just gets rattled off. So some more tape on the cable connector and we're ready to go. Here's a full power run from the mid-torque with the help of the plug-in.
So it looks like we'll have to start getting some clip-in connectors instead of the XC40 connectors. Wow, that's actually quite an improvement up here.
484, not bad at all. I'll be honest, there were some doubts among us that this power box would even move the needle. We figured that the gains, if any, from this would be around
Haters
the
gonna
end,
hate.
where the battery voltage might be worse from working longer and now facing even tighter stuff. But so far, seems to be in the middle. It's interesting. We'll circle back in a bit to see this versus an HD 12.0. Our next contender is the 2767 high torque. This should represent a bit larger current draw and therefore more voltage sag. Let's find out. Here's this original BCS run. And here is the OSHA No-No Box plugged into it.
Oh, these guys have some good names for this. Whoa. That is a huge difference.
$826, not bad. A noticeable increase in ugga-duggas felt at the wrist too. And a sort of warm, fresh plastic smell coming off this thing now, which is new. The sketch factor on this House of Horrors box is off the charts. And we're just getting started. Sketchy fact number 1, when you plug this thing in to an impact, the lights come on every time without touching the gun. That's fun. Sketchy fact number 2, if your shirt touches the screws on the back of this gun during a power run, the whole thing cuts out. Not during...
So, I guess my typical process for using this is whenever I add it to a tool, I'll leave it unplugged, I'll put it into the tool, and then plug the unit into the power or turn the power strip on or whatever. I tried to stay away because it does have some weird, it's got some weird behavior when you do that, A, and B, I've heard it, electrically arc before, so I'm pretty sure I included instructions on installation, but we all got to try it, so let's see what else we got.
Free spinning, but under load only. We thought the gun or the power transformer let the smoke out initially, but no, a hard reset, and she's good to go again.
And that's weird, because I've never had an issue where it cut out like that from, I guess I haven't had exposed fasteners. I would wonder, I don't know, I guess if you've got any ideas on how it's grounding out or what it's doing, put it in the comments below. But I'm not sure, because theoretically those fasteners are in the plastic unless they're structural with the motor. I don't know.
Sketchy fact number 3, if you aren't wearing rubber-coated gloves, this whole apparatus, again, cuts out when under high load. Like the user is acting as some type of live ground. That shouldn't be. No tingles felt either. It's sketch-tastic, though. Sketchy fact number 4, once this thing cuts out from such electrical threats as a cotton shirt brushing up against it, after unplugging it, it comes back online while unplugged, like a delayed capacitor deciding she's ready to become an electrical zombie. Real confidence in space.
Interesting.
So yeah, basically seeing that, let's plug it into our $1,000 M18 1-inch impact. Sounds legit. And no beating around the bush. This is the fail portion of the video. The 1200 watt max transformer is able to adequately supply this 1-inch in power modes 1, 2, but yeah, 3 and higher, not gonna happen. Max mode 4 sees almost no ugga-duggas. Harrison Hobbies currently doesn't have any plans to make another bigger one of these, but I mean, come on, wouldn't you want to see
Not true.
what 1500 watt box?
Not true.
Maybe bigger cables, connectors can do? Heck, maybe not even a 18 volt one, something like a 24 volt model that can be turned down to 21 to 22 volts. Then over voltage these bad boys and see what beans we can get or if bad things happen. We'd be happy to supply the parts for that effort, so head over to his channel in the links below and tell him yourself that you want to see it. Up until now, we haven't been putting Milwaukee's best stuff up against this wall power source, so let's see some HD 12.0 action. Looking at the power curve here of the mid-torque, it's clear that the copious 21700 cells in the HD 12.0 are bringing some serious out-the-gate discharge rate that by our math should be outpacing even a 1500 watt wall plug anyways, so it makes some sense. But ultimately, somehow, for reasons we don't know, the transformer is making some better numbers. In the middle again, we just find that sort of interesting. And here's the high torque. The discharge rate of the HD 12.0 is more sharply apparent here, but also not sustained long. The wall box just making those gains again in the middle, even compared to that massive
Harrison Hobbies engineering prowess at work here.
To our experience a bit
Undefinable.
with the Metabo HBT corded adapter that on average made less power when plugged in. But imagine the less legit nature of this House of Horrors box. Maybe sending some of that current unregulated as much as it can could play a part in that. We don't really know. But curious as to your thoughts, and we want to hear how you might improve this and make a non-deadly but more powerful version for Harrison Hobbies to make next, since we don't want to steal his video series. Appreciate you joining us for this one. Click subscribe to see the next one, and thanks as always for watching.
How do we pause? There we go. Okay. So, let's stop that one. Okay, so we got that video recorded here. So let's talk next steps. So I do have every intention of doing this. I would love feedback. What I've been doing, I know with shipping delays and stuff, I'm seeing them all the time. I wanted to try to get a little bit of inventory here, some stuff that we can start playing with. So the first thing that we got for the next steps here, this is another power brick here, identical to the old one, right? Same 66 amp, 18 volt, 1300, 18, 1500 watts, whatever, 1200 watts? I don't think so. I don't know. But it's the same as the other one. And then we got some of these boost transformers. And so this will allow us to put in a 18 volt and then on the output side here, we'll be able to get up to 50 volts. And so we got some potentiometers here for just different line levels, and so we can dial that in. My initial thought was, yeah, let's get this up to, you know, the 24 volt. But, you know, with these 18 volt, you only have about 1 or 2 volts of headroom on these. And so if we were to go with a 24 volt, we'd probably be capped out right at 25, maybe 26. And I don't know how the M18 tools cap themselves out, but there's a chance that they may allow us to go above even that. And so this one here is rated, I got 2 of these, right? So this one will go to the current power supply we've got, and we'll be able to dial in between 18 and 50 volts. And then we got this one here, which is the exact same thing. They're both 30 amp, 1500 watt. So combined, theoretically, I guess we'll be at around 2600 watts up to 50 volts. So plenty to break that. Got another power cable here. And then the torque test channel was also making fun. Apparently, whenever I grabbed it, I had a pile of cables, electrical, cords, and then I, cut the end off. These are just standard. I guess this is a higher amp computer one, but I'd accidentally grabbed like an 18 gauge, which is quite a bit. But again, this isn't a continuous duty, so you're not going to be killing everything. We got a hobby box, so we theoretically can put our, our boost converters into that. And then we got some more moderately sized siliconized wire here, so hopefully it's a little less cumbersome than what we had before. We got some more of these. Again, these are the connectors. I'm not sure if we want to move into like a click type, something that can handle the current. And then the last thing is, I've already kind of started work on this a little bit. We've got an 18 volt here, M18 Super China battery. And then this one was supposed to be the XC 6.0. Looking at the circuit board here, I was hoping that we'd have more current capability. But I think that the board is identical to the one that was on the 2 amp hour that the original pack was built with. So we'll try that. We'll see. I guess we'll have to see what happens there. But hopefully this can. I think, one of my viewers, he tried, I think he put 2 of these in parallel and hooked them both up to the littler battery, and he was running into issues where it was cutting out on like the M18 table saw. So I think if you read through one of the videos, I don't remember which one it was, but it had some kind of history on that. So I think that's going to be an option potentially with this. If I have this cut out, and again, we can simulate. We can do max current draw. We can take a C-clamp or something and put it on the miter saw, and then butt it up against the housing of the unit and pull the trigger and see what kind of max current we draw before it cuts out. So that shouldn't be too big of an issue. The other piece that we may need here, I've got some diodes, and so my fear is that as we get some voltage sag in one unit versus the other, if we don't have them perfectly timed in, we'll see a lower potential voltage in one of these, and we have potential for a unit that's maybe performing a little bit better, a little bit higher voltage, back feeding in, and so you can do bad things if you're trying to push current the wrong way. So hopefully those diodes will arrest some of that back feed, and we will we'll be a little bit better off, a little bit more safe there. But what I was saying about these, the battery packs, was that if this doesn't seem to work, then I hope to, if you, watching this video have any ideas on, how we can change this, what we can buy and solder on to make this more robust. If you think it's like a MOSFET issue. I don't think these have MOSFETs. I don't think they're switching. But, figure out if you have any idea what the limiting factor is, what would cause us to cut out in a way that we could either short it or replace a component or something to get a little bit more oomph and throughput. That would be appreciated. If I don't hear anything back here, then we'll potentially reach out to other YouTubers and maybe, make this even more robust. But this was a fun little reaction video, I guess, and next steps here, and we'll keep this going. So again, make sure you liked and subscribe to this channel, hit the bell icon so that as we progress with developing this stuff, everybody stays in the loop and we can all kind of contribute here as a community. So thanks for watching. Check back soon for more videos.